What if we could scan the entire sky and uncover secrets hidden since the dawn of time? What if a single telescope could reveal how galaxies formed, how the universe evolved, and whether life-friendly molecules exist beyond Earth? Well, on March 11th, 2025, a groundbreaking telescope called SPHEREx launched into space with precisely that goal in mind. SPHEREx, short for Spectro-Photometer for the history of the universe, its mission is surprisingly straightforward. Capture an all-sky map in unprecedented detail and help us piece together cosmic mysteries. From unraveling the history of the cosmos to identifying key ingredients for life, SPHEREx is set to offer a fresh perspective on our place in the cosmic story. In this video, we'll be discussing its mission objectives and scientific goals, its technological innovations, working and potential discoveries we can expect, and future research. So let's dive right in. When people say all-sky survey, it might sound like any other astronomical project that takes pictures of the sky, but SPHEREx's objectives go far beyond snapping pretty photos. At the heart of its mission is an effort to map the cosmos in near-infrared light, that band of the electromagnetic spectrum just beyond what our eyes can see. By doing this, SPHEREx will measure the glow of countless galaxies, both near and far, helping us track how the structure of the universe has evolved over billions of years. But it's not just about galaxies. SPHEREx also aims to explore the epoch of reionization, a critical phase in the universe's early life when the first stars and galaxies dramatically altered their surroundings. By looking at subtle signatures in the infrared sky, scientists hope to figure out how and when light from the earliest objects reionized the cosmos, effectively turning it from a foggy, neutral state to a clear, ionized one. In addition, SPHEREx takes a closer look at how the building blocks of life might be scattered throughout our galaxy. Specifically, it'll seek out water ice and other biochemically important molecules around newly forming stars. These ices can offer crucial clues about the conditions that lead to planet formation, and possibly life itself. Understanding where these molecules form, how they move around, and how they survive in hostile cosmic conditions is vital for anyone curious about life's origins. In short, SPHEREx has a trio of big questions on its plate. How did the universe begin and evolve? Which ingredients for life exist in our galaxy? And how do new stars and planetary systems incorporate these ingredients? With these objectives, SPHEREx stands poised to rewrite large portions of the astronomical handbook. You might be wondering what sets SPHEREx apart from other telescopes. After all, space is home to an array of observatories. The key lies in SPHEREx's unique ability to survey the entire sky in infrared wavelengths at high resolution, providing not just images but spectral data at numerous color bands. Think of it like going from black and white snapshots to a full spectrum analysis. Suddenly, every pixel is packed with information about the objects it represents. So how does this technology actually work? SPHEREx is equipped with specialized optics and detectors that split incoming light into dozens of spectral channels. This isn't just for show. By separating light into different infrared bands, scientists can discern the chemical fingerprints of molecules such as water, carbon monoxide, and other compounds essential to the formation of stars and planets. Each color channel highlights a unique piece of the puzzle, allowing astronomers to map everything from the distribution of cosmic dust to the faintest glimmers of the earliest galaxies. Because SPHEREx was designed as a smaller mission, what NASA calls a small explorer, its compact form had to be packed with incredible efficiency. Every ounce counts in spaceflight, so the mission team engineered the telescope to be both lightweight and power efficient without sacrificing data quality. A robust thermal control system helps keep the instrument's detectors at the right temperature, which is critical for infrared observations. Even slight temperature variations can spoil sensitive measurements, so the mission team had to innovate in everything from cooling systems to electronics design. All of these technological feats come together to make SPHEREx a sort of cosmic cartographer. In just a few short years, it will have scanned the entire sky multiple times, amassing one of the most comprehensive infrared datasets ever collected. These innovations ensure that SPHEREx isn't merely following in the footsteps of previous missions, it's charting its own groundbreaking path. So, what does all this mean for astronomy and our understanding of the universe? Let's start with cosmic structure. As SPHEREx collects data from billions of galaxies, researchers expect to create highly detailed 3D maps of where stars and galaxies cluster across the universe. These maps can help us test ideas about dark matter and dark energy, the invisible forces that shape the cosmos. By comparing how galaxies are distributed at different points in cosmic history, astronomers can refine our models of how the universe expands and how structures form on a grand scale. Next, consider the search for life. When SPHEREx highlights regions rich in molecular ices and organic compounds, scientists can pinpoint areas of the Milky Way that might be particularly ripe for planet formation. Although we can't see alien life forms directly with SPHEREx, identifying cosmic neighborhoods that have water and other vital molecules is a major clue in the hunt for potentially habitable worlds. Over time, future missions can zoom in on these promising targets with more focused instruments, possibly discovering exoplanets where life-friendly conditions exist. Additionally, SPHEREx's study of the Epoch of Reionization opens a window into the universe's childhood. By analyzing faint infrared light from ancient galaxies, astronomers can figure out how those early objects contributed to changing the universe from neutral to ionized. This not only satisfies our curiosity about cosmic origins, but also offers insight into how galaxies and black holes formed and evolved in the early eons. Finally, because SPHEREx will deliver such a wealth of data, it's likely to become a go-to resource for countless other research endeavors, some not even imagined yet. Whenever scientists want to cross-check a galaxy's infrared signature, locate a stellar nursery filled with ices, or track the distribution of dust in a particular region, they'll have this massive SPHEREx database at their fingertips. In other words, the mission isn't just about singular discoveries, it's about fueling future discoveries across all areas of astrophysics. So to conclude, in a universe filled with unanswered questions, from how galaxies assemble themselves to whether life's building blocks are more common than we think, SPHEREx arrives as a powerful new tool. Its infrared all-sky survey will generate an incredibly rich data set, shining a spotlight on everything from the very first moments of cosmic illumination to the chemical recipes that shape young stars and planets. Best of all, you don't have to be a scientist to appreciate its potential. The more we learn about our cosmic address, the more we understand how precious and interconnected life on Earth truly is. As SPHEREx continues its voyage, expect surprising revelations that challenge our assumptions and expand our horizons. Who knows what hidden wonders lie out there in the vastness of space? With SPHEREx, we're one giant step closer to finding out. For more updates, subscribe to Amazing Space.